Welcome to Hari Chemistry. So today's session we will discuss the continuous lecture of salt analysis, lecture number 2. So today's session we will discuss identification test for anions, that is acidic radical. The last lecture we discussed the preliminary test for the salt type of salts. So now today's session we will discuss the group 1 anions. So that is, in the anions or acidic radicals are classified into 3 categories. That will be group 1, group 2, group 3. Now today's session we will discuss continuous group 1 anions. The complete analysis of group 1 anion we will discuss today's session. So don't skip the video, student. So watch the video continuous, right? So if my efforts are valuable, so please like the video, share to your friends. It will help to my channel also. Okay, right. So today's this session, the acidic radical, actually the group 1 anions we will discuss today. The acidic radicals which give volatile products with dilute acids are treated as group 1 anion. This is already we know very well, right? In this group 1 anion, student, we have carbonate, acetate, sulfite, nitrite, thiosulfate and sulfide ion are placed in the group 1 anion, right? Okay. So generally the preliminary test for the identification of carbonate is releasing of carbon dioxide. Acetate is releasing of acetic acid vapor, that is the fruity smell, right? And SO3 minus 2 releases SO2 gas. Nitrite is releases NO2 and thiosulfate also releases SO2 gas. Thiosulfate also releases SO2 gas and S minus 2 releases H2 gas, right? Right. Now, so we will discuss the test for carbonate, that is the CO3 minus 2, right? Okay, right. So in this test, student, so take the salt in a clean and clear test tube, add diluted HCl or H2SO4. When we added dilute H2SO4 or HCl to this salt, then it will start a reaction and it will give a colorless and odorless effervescence that will indicate bubbled gas, which indicates the carbon dioxide is released from that reaction, right? So in this reaction, student, if our salt is containing carbonate CO3 minus 2, that will reacted with the HCl and this will be plus minus and this Na plus reacted with the Cl minus and it will form sodium chloride and H2CO3. This H2CO3 is decomposes into carbon dioxide plus H2O, right? Similarly, in place of HCl, dilute HCl, you can take diluted H2SO4 and it will give sodium sulfate plus carbon dioxide plus water, right? Now, this released carbon dioxide is passes through the lime water or slacked lime, then it will give a CaCO3. So that is a milky white insoluble precipitate is observed, right? Now this insoluble milky white calcium carbonate compound is treated with the excess of CO2 and H2O, then you will get CaHCO3 twice, that will form a soluble compound, right? So this is the general reaction, student. The released carbon dioxide treated with the slacked lime or lime water, you will get a calcium carbonate, a milky white insoluble precipitate, and this insoluble precipitate is again treated with the excess of carbon dioxide and water, you will get calcium bicarbonate as a soluble compound, right? So this is the test for carbonate, right? And one more test also there, that is the confirmation test, right? If you take the salt solution and add BaCl2, so salt solution containing what? Carbonate. So it will reacted with the barium chloride. So barium plus 2 reacted with the CO3 minus 2 form a barium carbonate as a white precipitate, right? Okay. This is a generally double displacement reaction, right? Barium is reacted with the CO3 minus 2 and that Na plus reacted with the chlorine and form, right? So this is soluble, this barium carbonate is soluble in diluted HCl, right? The color of BaCO3 is very important, student. It is a white precipitate, right? Okay. Next, we will move to the second test for our group 1 anion, that is the test for acetate, right? Okay, right. In this test, student, just take the salt and add a few drops of H2SO4, then heat the mixture for few minutes. So generally it will produces some vapor, that is the vapor will be released. That vapor or smell of vinegar is observed without evolution of any gas, right? Just it will releases some smell, that smell will be look like a vinegar. Based on that, so we can predict maybe acetate is present, right? The result is what? Maybe acetate is present, student, right? Now, so what are the confirmation tests for this, student? If you treated with the lead acetate, reacted with the dilute H2SO4, if acetate is present, that acetate then followed by the heating above reaction, then you will get a PbSO4 plus acetic acid. It is like vinegar smell. That maybe results acetate is present, right? Now we will do the confirmation test for this particular acetate, right? Okay, so take the salt solution or water extract and freshly prepared a neutral FeCl3. This is very, very important. So then you will get a blood red color, student. So this is a iron acetate, so it will form a blood red color, right? Look at, student, this is the salt solution. So we added neutral FeCl3, right? After few minutes it will be converted into Fe3 acetate complex. It is a blood red color, right? Okay, so this is the, if the blood red color is formed, then we can predict that compound will be present as acetate ion, right? Okay, so images and everything here it's displayed, student, right? So here I put more efforts for this making video, right? So please like what efforts I am doing for the making of video, so it will helpful to you, student, right? So for easy to visualize and easy to answer the question in the examination point of view, right? Okay, right. Next we will, and one more note, important point, student, this is the mains point of view, it is very important. In the FeCl3 test, that is the neutral FeCl3 test for acetate, the solution must be neutral and must not contains which anions which precipitate with Fe+3 ions, right? For example, if that particular salt contain carbonate, so this is not right, it is not give the test, and sulfate and phosphate I minus, right? So these type of ions may be present, so then neutral FeCl3 is not useful for this particular anions, right? I minus is oxidized to I2 by Fe+3 ion, right? So which produce reddish brown color. Actually I2 will be, iodine will be, generally it is a violet color, right? It color changes into this, right? Okay, then the confirmation test for this acetate, right? Okay, this is the general state, student. So this is we studied in the practical organic chemistry, that is the identification of alcohol and identification of carboxylic acid. The same test we are performing, right? So take, this is salt solution, add 1 ml of ethyl alcohol and 5 to 6 drops of diluted H2SO4. Then it reacted with the concentrated H2SO4 with ethyl alcohol. So then here water will be eliminated and it will produce some vapor, right? So that vapor will give the fruity smell. That fruity smell is nothing but that ester is obtained, right? So based on that ester formation, so then we can confirm that particular compound, that salt compound is having acetate ion, right? So this is the second test for acetate ion, student. Then we will move to the third test, that is the test for sulfide ion. So this is very, very important, student, right? Because 2025 advanced paper question from this particular paper 2 question from this sulfide only. We will discuss the question in this 2025 paper 2 question, right? Okay, so usually, student, just take the salt and add dilute H2SO4, right? So then followed by heating. So when this sulfide is reacted with H2SO4 followed by heating, it will gives a colorless gas. It will gives a colorless gas with rotten X smell. So that is nothing but sulfur like, okay, H2S is evolved on heating. So this may be S-2 sulfide ion may be present. So Here we are doing sodium sulfide on reaction with H2SO4 followed by heating. It releases hydrogen sulfide. It will is a Roten X-Men student. This is most important. And so byproduct is what? Sodium sulfatate. Okay. So if you are very good in salt analysis student, generally salt analysis is a factual only. It is a practical only. More number of times recall is very, very important. More number of times repeating is very, very important. If you are very good in salt analysis student, your block chemistry will be very, very good, right? Okay. So then we will move to the confirmation test for this particular, right? Okay. So confirmation test for these particular sulfide ion, right? So take sodium carbonate extract, simply we can call SCE, right? This sodium carbonate extract, add lead acetate, then add acidify, right? Okay. So before adding lead acetate student, so sodium carbonate extract, then you can acidify with the dilute H2SO4, then you can add lead acetate student, then you will get a block PPT. So this is the block PPT that indicates lead sulfide is obtained in that particular test tube, right? Okay. The reaction student, lead acetate Pb plus 2 reacted with the S minus 2, Pb plus 2 S minus 2 reacted, and you will get a block PPT of lead sulfide and acetic acid is obtained, right? Next. So second confirmation test student, this is also most important student. Cations also the test will be repeated, right? Take sodium carbonate extract to acidify the sodium carbonate extract by adding dilute H2SO4, then add cadmium carbonate to that mixture, right? So after some time it will form a cadmium sulfide as yellow color, right? Cadmium sulfide as yellow color. That S minus 2 reacted with CdCO3 student, you will get a yellow color cadmium sulfate is obtained, right? So this is the confirmation test for sulfide ion. And one more confirmation test student, right? So this you can take sodium carbonate extract and so alkaline solution of sodium nitroprusside. Actually sodium nitroprusside also violet color only, right? So then we will add this alkaline solution of sodium nitroprusside, then it will be converted into dark violet color. So this is the reaction student. Sodium sulfide reacted with sodium nitroprusside, iron oxidation number will be plus 2, NO will be acts as a NO plus nitrosonium ion, and these two sodiums added here, Na2 become Na4, sulfur enter into the coordination sphere, and this is a violet complex is observed when reacted with sodium sulfide reacted with the sodium nitroprusside, right? Now look at the question student. This is the G Advanced 2025 paper 2 question. During the sodium nitroprusside test of sulfide ion in an aqueous solution, one of the ligands coordinated to the metal ion is converted to, right? So NOS minus is given, SCN minus is given, SNO minus is given, NCS minus is. So look at the reaction student. Simple. Initially we have NO, that S will be enter into the coordination sphere, then our answer will be what student? NOS minus is the correct answer. This is the answer is given by IIT, right? So this type of questions are asking student. Only the thing is more number of times revision is required for the reaction. You can write the reaction more number of time, then it become very, very easy, right? Okay. Now then we will move to the next test student, that is the test for sulfide SO3 minus 2, right? So take solid compound and add dilute HCl or H2SO4 student. So then this HCl is reacted with this unknown solid, then it will produce some vapor. So that is nothing but student SO2 vapors it is produced, and it will give a pungent color smell, colorless gas with a pungent smell like burning sulfur. Pungent smell like burning sulfur, right? So burning of sulfur also will give pungent smell, right? So right now this vapors, this SO2 vapors are treated with the potassium dichromate. Filter paper is wetted with the potassium dichromate, and that filter paper, orange color filter paper, turns into green color. So that means student chromium plus 6 is converted into chromium plus 3, right? It is reduction reaction. So SO2 is, right, SO2 is, it is undergoing a reduction reaction. So it is reduces, right? So it is reduces potassium dichromate to chromium plus 3, right? Similarly, student, a filter paper wetted with the potassium permanganate color will be usually violet only, right? Purple color. Then after that, it will turns into the pale pink that released the SO2 gas, right? Student, these are the reactions, student. Sulfur dioxide released from that test tube reacted with the MnO4 minus potassium permanganate purple, then it will turns into pale pink. Reactions are most important, student. Just revise the reaction. K2Cr2O7 reacted with SO2, that is released. Then you will get K2SO4, and look at, student, this is the orange color turns into green color. This reaction most of the student already studied in the D and F block element. Redox reaction also, these reactions are repeated. Just revise these reactions, student, right? Okay, remember, student, potassium dichromate, that orange color turns into green color. Potassium permanganate, that purple color turns into pale pink, student, right? Next, one more confirmation test, student. Just that compound is having SO3 minus 2. So just take the sodium carbonate extract acidified with the dilute HCl, then add barium chloride dropwise, then white PPT is observed. So SO3 minus 2 acidified with the dilute HCl, add barium chloride dropwise, and you will get barium sulfite as a white PPT. Barium sulfite as a white PPT, student, right? Barium sulfate also is there, same white PPT only. It is oxidized with the bromine water, then BaSO3 converted into BaSO4. We will discuss in the sulfate reaction, right? Okay. Next, the fourth test, student, test for nitrite NO2 minus. This is also very important for the examination point of view, student, right? Okay, right. So one note point is there, student. This test should not be performed for nitrate in presence of nitrite Br minus and I minus, right? Okay, so here this test cannot use if that particular compound, salt containing nitrite or bromide or iodide will be present. So this test not suitable for the nitrite ion, right? Okay, so then what is the process here we are doing, student? Take the salt in a clean and clear test tube, add dilute H2SO4 dropwise, then followed by heating, right? After few minutes, student, light brown pungent fumes are evolved, right? Light brown, very important, student. Light brown, look at here, light brown pungent fumes are evolved. So that indicates NO2 minus nitrite ion may be present, right? Okay, so this is the reaction, student. Sodium nitrite reacted with the dilute H2SO4 followed by heating, so you will get HNO2, right? Okay, so these reactions most probably you studied in group 15 elements also. Usually this HNO2 is unstable, student. This is easily decomposed and converted into HNO3, H2O plus NO. Reaction is most important, student. Here nitrogen oxidation number is +3, nitrogen oxidation number +5, and nitrogen oxidation number +2. So then it is decomposed, student. So a nitrogen is reduced into +2, oxidized into +5. Most probably we can say it is a disproportionation type of reaction, right? So this colorless, it is a NO is a paramagnetic substance, student, right? Odd number of electrons are present. This colorless nitric oxide is reacted with air, so then it will produces brown colored gas, student, that is evolved gas. That evolved gas indicates that NO2 minus is present in this particular salt, right? Now look at, student, the confirmation test we will discuss, right? Now take that nitrite containing salt, right? Add diluted H2SO4, then add drops of iodine, then add starch solution, student, then the compound colored into bluish color, right? So the starch, after adding the starch, then the colors of the solution is blue color, then that indicates what, student? Nitrite ion is present, right? The reason is this nitrite ion reaction with I minus, this will be liberate iodine gas, right? Now this liberated iodine gas is treated with the starch solution, student, then it will form a bluish color. It can form starch iodine, a complex formation takes place. That complex color will be the blue color, right? And NO is releases, nitric oxide is released, right? Next. So one more test to student, this is also PYQ question, very important. Sulfolinic acid. So sulfolinic acid means nothing but, student, so this is SO3H will be there, para amino benzene sulfonic acid. So simply we are calling it as a sulfolinic acid, right? Sulfolinic acid and alpha naphthyl amine are dissolved in acetic acid in separate test tube, right? Take sulfolinic acid, dissolve acetic acid in one separate tube, and take alpha naphthyl amine in another test tube, add CH3COOH and make two separate solutions, right? Okay, these two separate solutions are added to the salt solution and form red azo dye, right? So this red azo dye indicates, student, the formation of conformation of NO2 minus is present, right? Reaction is very important, student. Already we know, student, this NH2 reacted with HNO2, very low temperature, 0 to 5 degrees centigrade. Usually diazotization takes place and it will form a, right, diazonium salt, right? Now this diazonium salt reacted with the acetic acid and HCl will be leave and it will form like acetate type of compound, right? So now this acetate reacted with alpha naphthyl amine. So reacted with this alpha naphthyl with the above compound, then it will form a reg azo dye. So this is the compound, student. Reactions are very important, student. Revise the reaction. Reactions are not that much of difficulty, easy reaction only, easy to understand. So finally this is the reg azo dye, student, right? This is the confirmation test for nitrite ion, right? So now last test we will discuss, student, the test for thiosulfate S2O3 minus 2. So already we discussed, student, if you add dilute HCl or H2SO4, so usually it releases what? SO2 gas, right? Now, so look at, student, this is salt, right? The salt containing S2O3 minus 2, add dropwise dilute HCl or diluted H2SO4 followed by heating, student. After some time, so yellow precipitate is obtained and it releases some acidic gas like SO2. It is a colorless gas with suffocating odor, burning like sulfur, right? Okay, now this released gases, potassium dichromate, right? A filter paper wetted by potassium dichromate, that orange color potassium dichromate converted into green color, that indicates SO2 is releases and it will give the positive test for S2O3 minus 2, right? Okay, S2O3 minus 2 reacted with H plus, student. This is most important. The yellow precipitate is due to sulfide and SO2 is gas is released. This SO2 gas is reacted with what? Potassium dichromate, that wetted filter paper orange is turns into green color, right? Next. So one more confirmation test, student, right? Take the sodium carbonate extract, right? Add AgNO3 dropwise and it will form Ag2S block. So before that, student, this S2O3 minus 2 thiosulfate reacted with the Ag. So generally it will form, so silver thiosulfate as a white precipitate. It is highly unstable. Immediately it will changes into Ag2S, then H2SO4. It will form a block ash into the block precipitate into the test tube, right? Okay, reactions are very important, student. Easy reaction, just you can add plus minus and it will be white precipitate, right? This will be converted quickly, changes into Ag2S plus H2SO4, right? One more test to, student. This is, you can take sodium carbonate extract, add iodine solution, then it will be converted into tetrathionate, right? So this I2 will be changes into I minus, right? So 0 to minus 1, it is a it is undergoing reduction. So I2 is a very good oxidizing agent, right? Now, so the reaction is the structure of S2O3 minus 2, student. Yes, right? So usually it is a ligand, student. It is a monodentate ligand only with a negative charge, right? It can bind with the metal atom with O donating atom. So if you shift here, this bond will be shifted. Maybe it will coordinate with the sulfur, right? Not coordinated with the both sulfur and oxygen at both oxygen. So only one donating site is available to coordinate the metal atom. And here the sulfur oxidation number is student here +6, right? Sodium tetrathionate student. So this is the structure. SS bonds are present. This middle sulfur oxidation numbers are 0, right? Here sulfur oxidation number is +5. Here sulfur oxidation number is +5. Average oxidation number is student 2.5, right? So the color of I2 disappear and reduced into I minus student, right? So that's it student. So this is the today's lecture student. So please like the video and share to your friends, right? Thank you.